don't know what this is. Yes, you can say it's the Pythagorean theorem. Fine. Oh, sorry. So you can say it's the Pythagorean theorem. Yes, but look here. I'm asked to find dA over dt, which means this is a function of time. I am given that dB over dt equals la la la, which means this is also a function of time. And I'm also told that dc over dt is whatever. So this is another function of time. So now when I differentiate both sides, I'm not differentiating variables. I am differentiating functions. Therefore, how do I get what I'm interested in? How do I differentiate both sides? What do I write for this? And of course, they are similar because it's a squared, b squared, c squared. So how do I differentiate the left-hand side? Anyone, just give it a shot. It's okay if you're wrong. I promise.
Is it 2a?
Times the inner function prime. Perfect.
dA over dt.
dA over dt, excellent. What about b squared? They're all the same.
2b times dB over dt.
Excellent. And for c squared?
2c times dc over dt.
Excellent. Here's what we are after. This is the only variable. That's all they're asking us to determine. They only want dA over dt. Uh-oh. I did lose power. Let me see if I have I do have a flashlight, but I have to look for it. I'll be right back looking for a flashlight. Oh, I got power back. No, I didn't. I'm lying. Still looking for the flashlight. So sorry. Look at this. I got my flashlight. It's a good one. Okay, you cannot see anything, can you? Is it working? Somewhat? Okay, so we are after this. Hopefully it's not going to take long till I get the power back. Okay, so is anybody else in the dark or just me? Just me? Okay, lucky you, good. Good, so first of all, I can divide every term by 2. So let's get rid of that. And then I also have to divide everything by a. So I have dA over dt equals whatever over a. So b dB over dt plus c dc over dt. That's all I need. And now we are asked to plug in all these numbers. What am I plugging in? I'm plugging in that a equals 13, b equals 12, dB over dt equals 0.25, and dc over dt equals 2. That's it. I just have to plug them in and it's done. So from here, I'm going to jump here and plug them in. B is 12. dB over dt, 0.25 plus C has to be determined times dC over dt, which is 2, over A, which is 13. Good, so I have to determine C. Remember, we have the original equation that states that A squared equals B squared plus C squared. So they are giving us A and B. Can we determine C? Yes, of course we can. How do we do that? So I have that A squared is 13 squared, which is 169. I have that B squared, 12 squared, which is 144. So plus C squared. 169 minus 144 is 25. So then C squared equals 25. We are told from the very beginning that everything is greater than or equal to 0. Because C squared equals 25, as we know, it has two solutions, plus or minus 5. But I cannot use negative because it's specifically telling us that C is greater than or equal to 0. So I have to use 5 in here. If my devices will die, that I don't know. I hope not. I still have some juice in the battery. Okay, so now in y equals, in parentheses please, 12 times 0.25 plus 5 times 2, which is 10. Don't forget to close the parenthesis. And we divide by 13. Oh, look at that, 1. Interesting. So what was the issue here? We had to differentiate both sides. We realized that these are functions of time because they're talking about dA over dt, they're talking about dB over dt, and they're talking about dC over dt. So all these are functions of time. So therefore, we carefully differentiate. We solve for the variable in question, and then carefully enter all the information. This is a linear equation now. After we differentiated, this is nothing. We solve for dA over dt. We plug them in, and we get the final answer. Okay, good. Is there anything else we want to work on? Do you want to work on another word problem? Do you want to work on anything else?
Let's do a word problem.
Okay. A spherical balloon is decreasing in size. A spherical balloon is expanding. And they're giving us the area, the surface area formula. The spherical balloon is expanding. Is that okay? Okay, very good. So let's read the problem. I'm sure you got the idea. A spherical balloon is expanding. Its radius is increasing by 0.5 centimeter per minute. Notice that each sentence gives us information. What is the information before we read on? What is the information we get from the first sentence? The spherical balloon is expanding, its radius increasing by 0.5 centimeter per minute. What do I have to write? Its radius is increasing at 0.5 centimeter per minute. I need to identify what this is.
Is that dr over dt?
Exactly. R, very clear because it's centimeters. T, very clear because it's minutes. Excellent. Good. Okay. Find the rate at which its surface area is changing at the moment when la la la. And I'll come back to that. So what am I asked to find? This is very important. And then we'll put in the information. But I need to know, what is this? Again, let's read that part again. Find the rate at which its surface area, and they give us the formula. Well, we had it, I wrote it. I wrote the volume, not the area. So they're giving us the area of the surface area of a sphere. Find the rate at which its surface area is changing at the moment when the radius is 40.
So we have to find dA over dt.
That's it. That's exactly it. That's what we're asked to determine. Good. And all these rates will be positive because everything is increasing in this case. Good. Perfect. So we have the formula. I put a dot underneath these. They look variable to be variables, but they're not variables. They are functions of time. So we need to differentiate both sides, keeping in mind that A is not a variable, R is not a variable. Can anyone help? What do we write on the left-hand side?
dA over dt.
Of course, dA over dt. Excellent. What do we write on the right-hand side?
8 pi r times dr over dt.
That's it. Absolutely it. Excellent. Good. So what are we after? Obviously, it's dA over dt. I don't even have to solve for anything. I just need to plug in the numbers. So this is it's very straightforward. So then dA over dt, I have 8, I have pi, I have 40, and I have dr over dt, which is 0.5. Now careful, can anyone give us the measurement unit of this? What will be the measurement unit after we finish calculating? So we have 8, and we have pi, and we have 40. It's 40 divided by 2. I could have entered 20, but that's okay. Okay, so for 8 times pi times 40 times 0.5. So 502.65. Good. Measurement unit. Measurement unit.
Is it centimeters squared per minute
Excellent.
area?
Excellent. That's it. As you see, there is very little difference, I would say almost none, with what we discussed last time with implicit differentiation. That's exactly what we did. That's what we did. Good. Do we need more examples? Do we want to work on the any of the revenue cost situation. So here it is. Find the rates of change of total revenue, total cost, total profit with respect to time. Assume that R and C are in dollars. Do we want to choose a problem like this, or we move on to the last section before my devices die? Anybody? Okay, let's move on to the last section, and we're going to review everything before the test. So please register for the test if you haven't done it already. Okay, so the last section that we have, I didn't skip it, I just left it at the end. So again, so let's go back here for a second. Previous class notes. Graphing, what we learned from these two about the function. Profit, max, min, cost, and so on and so forth. Implicit differentiation and related rates are very, very close to each other. How to find the derivative, an expression for the derivative when we don't have the function, or it's given to us indirectly through an equation. The same thing here. Related rates, what does it mean? An equation that has derivatives in it. And it's of course, it's coming from an equation that relates the functions. So the final step here is something called linear approximation and differentials. Okay. So this is 3.6, linear approximation and differentials. Okay. Let's suppose I have a disk. And the disk has a radius, or it's supposed to have a radius, very simple, 1 inch. 1 inch. But it doesn't. I made an error. It can be in minus or it can be in plus. So let's suppose the actual is 0.9 inch. Or the actual is, let's say, 1.12 inch. But it's not what it was supposed to. So let's say I produced myself this disk, but I did not produce it by specifications. I either have a little bit less in the radius or a little bit more in the radius. So I have an error in radius. That error in radius is called actual error, which is delta x. I used r, so I'm going to use delta r or delta x. If we call it x, it's delta x. So this is the Greek letter delta, delta. This is the uppercase delta, and this is the lowercase delta, which we will not use in this class. So this is a Greek letter, uppercase delta, lowercase delta. So the actual error that I made in this case, if I'm here, it's minus 0.1. And if I'm here, it's positive 0.12. But this is the actual error. Now, this error that I created will trigger an error in the area. That is the problem. Not only that my error gave me a smaller or larger radius, but it triggered a delta A. It created an actual, oh, I have light. Excellent. Good. So let me plug my laptop in. One second. Okay. Okay. So this is the actual error in area. Uh-oh. I guess they're trying, but they're not succeeding yet. So the error, the small error that I have in the radius triggered an area in the actual, triggered an actual error in the area. And this is called delta A. What does delta A equal to? It's the area including the error minus the area that you should, with no error, in other words. Area exact. How do we write this? And we're just going to use a function in a minute and just determine these. Good. So let's suppose I have a function, f of x, let's say x squared plus 2x. Let's suppose that x should be 1.1, or just 1, simple, 1. But actually, delta x is 0.11. So this is what x should be, but I have an error of 0.11. So right now, x plus delta x is 1.11. Because I have this error. Now, I want to find the actual error in f of x. So the error is delta f or delta y. The error in the function, either denoted by f or y, is the same thing. And that will be f of x plus delta x minus f of x. From the function evaluated with the error, I subtract the function that does not have error in it, what it should have been. And this will be the actual error in the function, triggered by this error that I made in x. So therefore, I continue. I find the value of f of 1.11 minus f of 1. This will be the actual error that was triggered